Well, good afternoon, everyone. I see you're in a very good basketball season mood. But we got something, I would say, just as exciting for you in the last presidential lecture of this semester. As you know, we are the cradle of astronauts. And today's presidential lecture is an alumna who is now the chief astronaut instructor at Virgin Galactic. And in 2019, February, she made history as the first female commercial astronaut. And since then, she's taken 6 space flights, making additional histories, such as being part of the first fully crewed commercial flights, along with another alumna, Shrisha Bandla, such as becoming the first commercial astronaut to be floating in a suborbital space flight. Please join me to give the warmest welcome back home to Boilermaker Beth Moses. Welcome back. So good to have you.
Thank you.
Well, Beth, we talked about your incredible journey from the cradle of astronauts to becoming one yourself, to training astronauts. Last time we met, pre-COVID, it's about 4 years ago, when you were visiting Purdue at that time. And, I want to ask you this question that perhaps some of you have not heard the answer. And I'm sure you get this question all the time, Beth. When you were on your first space flight, what was the most incredible moment?
Apogee, which is the highest point in the space flight. But first, let me say, thank you so much for hosting me. Thank you all for your time this afternoon. And I was born and bred here at Purdue. It is truly a cradle.
Yes.
Hardcore aero all the way. And when I hear myself introduced to this day, I can't believe that's me. I'm still like, wait, what?
It is you, Beth. I'm pretty sure. I got the bio correct. I double checked on Wikipedia. It's
okay.
Ought to be true, yeah.
You took the DNA sample? Okay. But it's I sort of have whiplash from my own life. It's a little bit astounding to be sitting here. And I'll also say, and then I'll answer your question, I promise. The moment in my life when I was the most proud of becoming a professional astronaut was not the day it happened, not the day I was selected, not the first day I flew, but the day I was informed that this university was going to include me in the cradle of astronauts. It meant...
Well, with the university, have the audacity to have the authoritative listing of astronauts, who counts and so on. And yes, well, we're so proud.
Being a Purdue astronaut is more than just being an astronaut, and I thank you. I thank you for that. So apogee is the highest point of a suborbital spaceflight or in orbit. I flew professionally with a suborbital space company, Virgin Galactic, and I'll take you through it briefly. We released, we boosted, we got to space. The vehicle turned and was wings level above Earth when it coasted, just ballistically, coasted all the way up to apogee. And inside, I was serving as a test engineer, and I unstrapped, strapped back in, went around the cabin, testing the hardware. And it was very busy, and I was scripted down to the half second, and I had rehearsed 4 different timelines, and I was on the job. I swear I was on the job, and I was even on task and on time. And then we reached the highest point in our trajectory. And at that point, we want everyone that flies in that vehicle whether they're employees or engineers or researchers or private astronauts, to look out the window. And so that day, that was my job, to look out the window and figure out how to best train it, figure out how to explain it to people, figure out how to prepare people for it, and figure out any gotchas, any issues.
Yes.
So we coasted slowly up to apogee. We came to a stop. And I was unstrapped, looking out the cockpit windows from the cabin behind the cockpit. And I had completely let go. And it felt timeless. I felt like the vehicle coasted to a stop. And out the window was the blackest black I'd ever seen, and the brightest Earth you could ever imagine. Pictures do not do it justice. Every picture you've ever seen from space is a shadow of what it really is with the human eye and the human heart. And it just felt like time stood still, and I could see the Earth below me. I could see what felt like halfway out across the Pacific Ocean, halfway up the US, for real, 1,000 miles, halfway up the US, halfway down the coast. The mountains on the west coast were covered in snow and glistening, with that icy snow. And it was just the most amazing feeling of being both infinitely small and meaningless. I mean, compared to the Earth, what am I? Who are we? I mean, that's all of life right there below you. And yet feeling exhilarated, excited, empowered, taller than tall, bigger than big, and at the same time connected to all of you. That was the most amazing takeaway from my first flight.
The Aero Astro class of 92, Master class of 94, who's also a poet. Now, when you were not writing poems as profound as that, and not taking care of your homework and final exams when you were here, maybe there's no much time left after that, but what was your favorite thing to do when you were first as an undergrad student, then as a graduate student at Purdue, and in particular, where was your favorite dining spot?
Not too far from here. Not too far from here. It was actually just the student union. And if there was like an ice cream and burger place, am I remembering correctly? Maybe Pappy's?
Pappy's.
Pappy's was great in those old wooden, benches. So as an undergrad and as a grad, let me just say, I was never the sharpest tack in the box, and I was never the student setting the straight A curve. I was always jealous of those students who could go to bed on time, because the Aero Astro workload was huge. I think it still is, rightfully so. And so I pulled many all-nighters as an undergrad, as a grad student, many times fell asleep over my work at Pappy's and had to shake myself awake and keep going. And that didn't end when I went to NASA. There were all-nighters, and at Virgin Galactic, there have been all-nighters. But being here at Purdue, my favorite places were actually, honestly, the terminal room in Grissom, because I was making progress and doing the work, and then sitting at Pappy's. And my favorite people were my fellow students, and I will say, one special fellow student who I ended up marrying. We will send you a bill later. Tonight, we charge a finder's fee. All the happy couples, both Boilermakers. And, you mentioned NASA and Virgin Galactic. So before 1 decade at Virgin Galactic, you worked for a little over 2 decades at NASA. Yeah.
So what was the difference like between your time in NASA and what you have been and currently doing at Virgin Galactic?
There is a big difference, but at the heart, they're both human spaceflight programs, and so they're both highly technical, require a lot of work, require all-nighters, require teamwork. At the heart, they're both very similar. I guess the biggest difference was scale. When I worked at NASA Johnson Space Center, I sort of grew up with the space station program, which evolved from, the drawing board and a single country project to being the International Space Station that we now know and love today, which was many countries. And that was all engineered within sort of the NASA ecosystem. And as a young engineer, a Purdue co-op, for which I'm extremely grateful.
Okay, you were a co-op. Huh?
I was a co-op. As a Purdue co-op working on the space station, within the NASA infrastructure, there was almost always someone I could call for help, a competent engineer, usually someone who had worked on Apollo or something, who could show me the ropes, second check, sanity check work, explain how things worked. When we needed test chambers for International Space Station hardware, like valves and whatnot, they existed. Maybe they were in mothballs from the Apollo program, but they existed. So within the NASA ecosystem, there was a large ecosystem that could be brought to bear. On the flip side, when I went to commercial space, especially new emerging startup commercial space like Virgin Galactic, the opposite is sort of true. There's nothing inherent in-house. If you need something, you have to go elsewhere and bring it in. And so having the NASA experience helped, but really new space, commercial space startups, we are creating, inventing, which can take more time, but also can be fast if you let it be. So the scale was the biggest difference to me.
What do you think is the future of commercial spaceflight?
Well, akin to Purdue, hopefully it's excellence at scale.
Hey, you've been brainwashed by our propaganda.
Not
It's
at
all true, yes. But what would scale be like in commercial spaceflight? How big will be the scale you want to see?
Oh, well, I mean, I'd love to see every human on Earth be able to go to space and look back at Earth, because I feel like we are all here for something bigger than ourselves. And I honestly think, and this is going to sound cliche, but I honestly think if we could lock the squabbling world leaders into a spacecraft and have them look down on Earth, maybe they'd stop squabbling. Maybe, you know?
One could hope.
Exactly, yeah. So to me, excellence at scale would be things like, and I'm in it for all the companies that are doing this. I mean, of course, I work for Virgin Galactic, and I've flown with Virgin Galactic, so maybe I'm a little biased, but SpaceX is already doing things at scale, repeatably. Blue Origin is building an infrastructure, suborbital and orbital. Galactic is only suborbital, but as an example for Galactic, excellence at scale would be 400 flights per year per spaceport.
Wow.
Wouldn't that be something? Excellence would be a fleet of spacecraft. Excellence would be flying more than once a day. Excellence at scale would be flying from more than one continent. And that is the vision. Those are all in visions for the future once we prove it out and start a fleet and start to grow. Also, since it's commercial, being highly profitable would be excellence at scale, because that's how you get to keep doing it.
Yes. There's been the sea change going from, hey, space flight, that's something only NASA on behalf of the United States government can do, right? What do you mean by startup companies? And now there's a whole ecosystem over the past 10 years and so. But also there is, it's closer to the moon here in the front row. I was talking to those who are watching online or watching the recorded version, we're waving to those who just entered to the back of the auditorium. But, I'm also a little worried that if you look at the commercial activities physically taking place, primarily in states such as Texas, Florida, there's a lot in California, in Colorado, right? Well, I want my state, the Hoosier state, Indiana, where Purdue serves as the public land-grant institution, right, to also be a participant, if not a leader, in the commercial space future. What do you see as a potential role that our state or the Midwest in general can play?
Well, for sure for Purdue, one major role that you can play is exactly what you have been so good at for all of your time, which is educating and creating the hardcore, humble engineers and workforce that the aerospace industry needs, or all of engineering needs. And I can only really speak for engineering, but it is still true that the most valuable, at least to me, employees, engineers, and coworkers almost always come from Purdue. They have a work ethic and a humility and a core competence that is always exceptionally valuable. They are always team players. You are always the rock solid sort of people that either are or help create the people that enable commercial space. And that's been true for decades. So very well done to the university. So in addition to workforce, talent, core competence, I was sharing thoughts with your engineering dean earlier today. There's all kinds of areas that could use help. We struggle with valves, the whole industry. We struggle with structural analysis. We struggle with scale. You could make more engineers. Please, please, please make more engineers. That would be lovely.
Yes, well, workforce and innovation. We have outstanding faculty and students, including PhD students, who work not only in AAE, but throughout many departments and colleges at Purdue on a variety of groundbreaking research results, right? Including some that are funded by, say, NASA in the resilient extraterrestrial habitat. We've got outstanding faculty who look at the systems, the avionics, they look at the fuel, they look at the aerodynamics, they look at how to avoid the litter in outer space, in the trajectory, right? And then they find ways to, let's say the moon, get back on the moon again and stay there and go beyond. Now, you also develop internal workforce as the chief astronaut instructor. I know that you are here in part because of the selection by students as a member of this year's cohort of the Old Masters. And you've been an inspiration to many Purdue students. Now, when you go teach to these future commercial astronauts at Virgin Galactic, what do you think is the toughest thing that they have to learn from you?
I think that depends whether they're employees flying as employees or whether they're customers. And it also depends on what their objective is for their flight. Perhaps the most important thing for them to learn, frankly, is how to get back in their seat. Please get back in your seat on time.
Okay.
If you just, because we are suborbital and ballistic. So when we get to space, you can unstrap, you can enjoy the view out the window, you can float around, have the hair moment, all that kind of thing. But then no matter what, the vehicle is coming back to Earth. We don't, we're not orbital. We don't have extra engines. We're coasting up, we're coasting back down. And so when we re-enter the atmosphere, it's best if you're back in your seat. So that's the important thing, and that's
seatbelt.
Seatbelt, literally seatbelt. Nothing. It's literally a 5-point harness, but that's one thing. And of course, then there's the concepts associated with the flight profile. When you unstrap in our vehicle, no matter what you're doing, the vehicle will then move about you. So if you're unstrapped and floating weightless, and the pilots use an air jet to steer the vehicle in space, it's going to move with relation to you. And you just need to be aware that that can happen and sort of what time frame it's going to happen on and that it occurs. And then simple things like where's the oxygen mask in case you need it, which you should never need. Very, very unlikely, but simple things. And then also we aim to either enable a research platform or an exceptional private astronaut experience. And so it is important to learn sort of what's going on around you and the timing thereof so that you can get done what you want to get done, even if that means doing nothing in your flight. For the employees that fly, they're generally doing very, sometimes complex, but very scripted testing.
Right.
So it's important for them to learn their procedures, backup procedures, timelines, where to be when and what to do and how to rate it. We use, for the real aviation geeks in the audience, we use a modified Cooper-Harper scale that was developed for the International Space Station by my spacewalking teams to evaluate hardware and procedures. And it's important to know how to do that and do it sort of methodically. So we train that. And then we explain our system, which has a different architecture than any other system. We explain how we are air-launched, and how we glide back home. So those are the examples.
Well, I know that you're going to be participating at the Old Masters panel later this evening.
Yes.
And that's why we have this unusual time at 4 to 5 o'clock, usually 6 to 7. But I know that you've got a whole busy day for you here back on campus. Now, I'm sure students will probably be wondering about risk-taking, especially when you were the first to try floating as a commercial astronaut, right? And you don't know what you don't know. You try, you prepare yourself, you be resilient, but then there's that moment, you are taking a risk. And so how do you handle with your mindset on taking risks?
Well, first of all, I chuckled because I didn't know I was the first. That's going to sound crazy. I mean, now it's like, a milestone and achievement.
Then they told you, by the way, nobody had done that before.
Right. That's exactly right. Actually, the journalist figured it out. And I was like, oh, okay. So I'll tell that story briefly just because, at least I find it kind of funny. Well, I'll tell a few stories. So Virgin Galactic was the first company, private company, to put humans into space in late 2018. Before that, NASA for the US, the Russian program and the Chinese program had launched humans to space. And there were several commercial companies that were working on systems to launch humans to space: SpaceX, Virgin Galactic, Blue Origin. And Virgin Galactic achieved that first in December of 2018 with 2 pilots and crash test dummies. And it went so well that the pilots said, okay, well, let's swap one dummy for another dummy. And I was selected to fly. And it was, the 2018 flight was so successful, it got all the data it meant to get, and the data all looked so clean that we suddenly found ourselves as a program, as a company, in a position to start testing the cabin with an engineer. And we were ready to fly pretty quickly. So I only had, a few weeks between the time it was sort of, posited that we should put someone in the cabin till the time I flew. So I didn't really have time to understand the historical significance of it. I certainly had time to assess the risks. At Galactic, I was in charge of the cabin test program and had written the test plans and had assessed the hazards in the cabin, on the ground and on the drawings. I knew the cabin like the back of my hand. And I was in all the reviews that tracked the progress and the testing of the vehicle as a whole. So I knew, especially because I could look at all the data from the crash test dummies, that the cabin and the ship were safe. I did not feel like I was taking on risk necessarily. I felt like the system was safe. The experts around me had proven it was safe. I had no concern on that regard. And the point of the vehicle is for people to get out of their seats, enjoy the cabin, use the cabin, enjoy the view, get back in their seats. You don't have to, but if you want to. And so, of course, the test plan had get out of your seat. Now, to answer your question about approach to risk, I instituted an extremely methodical program. The very first test objective in that test plan was to identify the unknown unknowns. And so we all, but especially me, when I was ultimately assigned to do the test myself, we all went into it with the appropriate aerospace testing attitude of, we don't know what we don't know. We've controlled every possible risk that we can think of in various ways, and I'm happy to elaborate on examples if you want, but it's really what we don't know that we need to watch out for, and that's inherent in any test flying, any expansion of an envelope in any way. And we were sort of expanding the envelope with a human in the loop, me in the loop. So we did things like the first time I unstrapped, which was right after rocket motor cutoff, the very first thing I did was strap back in. Even though I didn't have to get back in yet, we had another 3 minutes or so before I needed to get back in. The question was, what if something broke during boost? What if I wasn't in my right mind? What if, a buckle had fallen off? What if the technique we thought we developed and tested on the ground wasn't appropriate? So the very first thing I did was check that I could get myself back safe. And it went fine. So then I got out again. And then I had my magic apogee moment. But we took that approach to every aspect of the testing. So as another example, and to get back to Purdue's work ethic, I took that flight and the planning of that test probably more seriously than almost anything I've ever taken in my life, because every second of that flight was priceless. It had taken a large team, many years, a lot of money to put the very first Pathfinder in space, and I wanted to get every morsel of information out of that flight that could possibly be gotten, because that was my responsibility. And Purdue's work ethic is similar. I mean, how many long, laborious aero projects and programs have, students sat through? It was that kind of thing. It was, do the maximum that you can do. So I rehearsed 4 timelines down to the half second, so that when we got to space, if the timing was different because the rocket motor was different, I could execute whichever one of those I needed to in order to get the most out of the test. We did things on that flight like I had trained for sharp edge detection. Just in case we got to space and something on the wall had cracked, I was very gentle in the cabin, and I wore sharp edge inspection gloves so that if I was the first person to find that something was sharp that wasn't sharp on the ground, I wouldn't get hurt. There was some risk of injury on that flight. I guess I'll explain. I'll be very forthcoming. The real unique aspect for that flight was that I was in the cabin on my own. We've not done that since. We only did that, once, and we did it purposely. The pilots in the front can't leave the cockpit. So before the flight, I knew that if anything were to happen and to go wrong, I would be dependent upon myself for any aid. And I, had a soulful conversation with myself. But my experience testing hardware at NASA in various environments had made me extremely comfortable that I understood the environment in Spaceship Two. And at worst, maybe I'd get a little dinged up, bruised. Maybe if I couldn't get back in my seat, I'd have to sit on the floor to come back. Maybe I'd get tossed and turned a little bit. But I was completely confident in the system, completely confident that the worst it would be sort of minor injury. And so I went into the flight confident about the risk trades that had been made. And in the end, there were sort of only, minor incidents, minor findings. And I got back in my seat the second time and came home and skipped off the ship, and all was well.
Well, now speaking of coming home and boarding again, you've altogether had 6 space flights and more to come, right? So altogether, I heard it's been 1 hour and 15 minutes collectively that you've spent in space. Some journalists, did that calculation for you too.
Thank God for the journalists.
Well, so how many times do you think you want to be on space flights? How many hours would you like to spend altogether in space?
All of them?
All of them. Do the maximal work possible.
So it's an honor to do the work, and I'm very proud that I am a working professional career astronaut. The aim of Virgin Galactic is not to fly employees, it's to fly our customers. And so actually, the mark of success is not for me to fly, it's for others to fly. That's what we're here for, and I really truly believe the world leader thing. I want the world leaders to fly, not, Joe Schmo engineer every time. So from that standpoint, I actually don't want to fly. From a human standpoint, and from the fact that I love it, I'd love to keep flying, but I want all of you to fly. I would put any of you up before I put myself up again, because I think it's important and it's cool and I want to share it, So I don't know. I don't know if I'll get the chance to fly again. Certainly if the company assigns me or we have a customer that needs help, then of course I would. I'd be happy to if I were selected. But in terms of like a practical answer, I do think there's a practical limit. If I flew every day, eventually I would need a day off, right? I mean, there is also life, right? I'd need to go to a family event, or I would need to, So
you could come back to Purdue.
And I would need to come back.
We don't have
Purdue.
a campus in space yet.
That's right. So in order to fly and come back to Purdue, I guess I'd say I would fly twice a day, 360 days a year, and then I'd come to Purdue for the other 5.
We'll take those 5.
Okay.
Now, part of this equation is the cost to partake, and you mentioned excellence at scale, right? And a lot of situations, the increase in scale will also help to reduce the cost. And I think a lot of us look forward to a day when that scale would allow the cost to be reduced to the point that fulfill your vision that anybody on Earth should at least do it once, right?
Yeah.
And I know that sometimes there's like frustrating situations between a couple. I've heard some friends say, well, I wish my, better half can just go onto a space flight and don't come back again, right? So, but you just assured us they will come back. No, you.
They will come back, yes.
But they will come back.
Yes.
That's disappointing. But by some. No, some friends. I'm not implying that I've been told that. But for that to happen, right? For whatever reason, motivation, the cost needs to come down here. So what kind of a basic cost equation do you think will allow this to be indeed enjoyable by a majority of the population? How big of a scale, back to that question, does it need to be to get to the point of affordable flights?
Yeah. Well, that is a great question for the financiers in the world. And I don't know the numeric answer. I know it is, a larger operation than we are currently operating, but I also know it has to start with a demonstrator. And so we, Virgin Galactic, we have just last week, Thursday, we flew our 6th flight in 6 months. That's historic. Even I, the non-journalist, know that that's historic. And it's a key demonstrator. And next year, we intend to fly flights with more customers, 4 customers, and not instructors, to demonstrate that capability.
Right.
Obviously, to continue this, we need to make more revenue, which means we need more ships flying more frequently with more customers. So there are some, analytical numbers there that you can that the journalists probably know.
Yep.
And then, we need each flight essentially to pay for itself, right? And then to bring the cost down to where many more people can afford it, we need it to not only pay for itself, but get efficient and optimized in order to bring the cost down. And I think that's common to any startup. I think that is just the way business and startups go. And we are on that successful, thank gosh, trajectory now. We've just demonstrated monthly flights. We need to get to weekly flights, bi-weekly flights, daily flights, or for at least 360 days. And then the cost should come down.
Well, I just can't help but to imagine the time when we all get to escape the surly bond of Earth once, and to be able to contribute through technological innovation to help rewrite the economic equation a little bit, in addition to the scaling up by companies such as Virgin Galactic. I think we're going to... Yes.
No, I have a question for you. Sorry.
Gee, I was about to turn it to the students.
No. No, because you brought it up, I'm going to ask you.
Oh, okay.
Would you go to space next to the IU president?
Well, I honestly don't see the point of having IU represented. I'm not being biased. I'm just telling the truth, right? You mean, it's not like they have 27 astronauts, including Beth Moses. And I think eventually, like many rankings and so on, eventually it will be IU's turn. I do not deny their rights to eventually be part of it. I'm just saying that I would like to go out there with my wife. This way we can both escape the noise of the kids fighting against each other for a little while. Maybe we should go with the kids. I'm making a lot of mistakes tonight here.
It's okay, you own the recording.
I bet it. All right, let's erase recording, yes. What's better than making histories to write it or rewrite it? But, well, before I make further mistakes, why don't we turn it to students, ask you questions. So we have a few students who might be participating in the O-Master process here to ask you questions, please. Oh, whoever is ready to ask questions. Over there, please.
Hi, hello. I just want to say, first of all, thank you guys so much for being here tonight and talking to all of us. I'm sure I'm speaking for everyone and saying that we've all thoroughly enjoyed your guys' conversations, and thank you for allowing us to ask you guys some questions. So my name's Samantha Glicky. I'm currently a junior in AAE here at Purdue. And Beth, I have a question for you. Yeah. So obviously your career has been so enriched. You've had so many amazing opportunities and done so many amazing things. We were wondering, what's your biggest piece of advice for anyone looking to go into the space industry, and who gave it to you?
That is a great question. I think it was Samantha?
Yes.
Nice to meet you. Good luck with AAE. What's my biggest piece of advice and who gave it to me? I'm going to split that. My biggest piece of advice and then something someone did for me. My biggest piece of advice now for the space industry is that it is massively expanding with the birth of commercial space, new space. And there is a place in that industry now for anyone and everyone. Historically, I used to at least view, when I was a junior in AAE, I sort of viewed it as the providence of engineers, scientists, pilots, NASA, that kind of thing. And I would have been shocked if you told me even that NASA needed other expertise, lawyers, et cetera. Now I can absolutely say, especially with the growth of commercial space, every field is needed now that it is both government and private and commercial and startup and not. And if you love space but don't think you're good at it and you instead feel like you have to be a whatever, just do that whatever in aerospace. There is a home for you. And it's super fun, super exciting, and a really good industry to work in. Really, I love it. I'm totally biased, but I love it. So, come on in. The water's warm. We need you. We want you. It's a good place to work. There's room for everyone. Of course, AAEs, no question, but also anyone else. And as I said at the beginning, Purdue is very well regarded. Now, who gave it to me? I'd like to hijack that question and tell another little story, because I would love the opportunity to say thank you again in a public setting to someone at Purdue that made a remarkable difference in my life. I came here as a freshman engineer, wanting to go to aerospace, wanting more than anything to build and fly spacecraft. I always wanted to be an astronaut and not just go to space, but work in space, build the vehicles. I can't remember a time I did not want that as a tiny, that was all I wanted. It is why I came to Purdue. It is why I went to NASA. I loved it and loved nothing else for my whole life. So you can imagine my trepidation as a stupid, clueless freshman trying to sign up for interviews for a co-op job. And I knew exactly when I had to sign up for interviews, sharpened my pencil, went to Grissom Hall where Aero used to be, went to sign up to interview for a NASA co-op job with my heart in my hand, and they were all full. I had screwed something up. I still don't know what. The day, the time, maybe everybody got there the day before and cheated ahead of time. I don't know, but when I went, all the slots were taken, and I was beyond heartbroken. That was like my whole, I wanted to work for NASA. I wanted to be a co-op. I had researched everything. I had stayed up all night to get the grades to qualify. And here I was with a sharpened pencil, not a single blank line on the page on the wall. And the co-op coordinator, Professor Gustafson, Gus, knew my plight and got me an interview anyway. And I got the job, and then I got the permanent job, and then I did all the station testing, and then I got the galactic job, and the station testing qualified me for my flight, and then my subsequent flights. And without Purdue, without the heart and soul of Purdue, which is helpful and humble at its core, without the people like Mung and Gus, none of that would have happened. So
Well,
I
here's
don't.
to Professor Gus.
Yes, here's the Gus. Thank you.
Well, by the way, this is, I think, one of the key reasons why some of the folks enjoy being in a university setting as a professor or as an advisor, as a staff, is that one little thing that you can do one morning could change the life trajectory of another life. And who knows what that life with the changed trajectory can do, like what you did. We have a few more students here, please.
Yeah, first of all, I'd like to thank both of you for coming out here and speaking with us today. My name is Karina Hollisbrow. I'm a fifth-year senior in aeronautical and astronautical engineering. And my question for you, Beth, is what is one of the reasons you decided to pursue and support commercial space?
Thank you for the question, Karina, and congratulations on making it to the 5th year. I'm sure you've had all-nighters too. I think the idea is, what drew me to commercial space? Why did I decide to go to commercial space? It's actually because I finished a big project, the space station, International Space Station. I started in the proverbial mailroom designing mock-ups as a 19-year-old co-op, and then I stayed with it, grew with it until assembly was complete on orbit. I was the lead engineer who was responsible for all the testing that verified all those systems. And one day we looked up and it all fit together and it was done. And we were like, pinch me. Oh my gosh, wait, it worked? Oh my gosh. And of course it was because of a lot of hard work and a lot of all-nighters at NASA and a lot of people who scratched their head and realized they weren't the sharpest tack in the box and got other people's help, and so it all worked. And then I looked around to see what was next, and commercial space was up and coming. And the center of human spaceflight and the torch of human spaceflight really at that time passed to the commercial space world. The contracting paradigm and procurement paradigm changed to where the companies that the US is incubating were going to be the developers, verifiers, owners, and operators of the spacecraft, and NASA was going to be the user, just hire a taxi ride, essentially. And that's what I liked doing, development, verification. And so the role that I had done at NASA for the space station for the next set of vehicles had moved to the commercial industry. So I likewise moved and then sort of grew up with Virgin Galactic.
Another question, please.
First of all, thank you again to both of you for allowing us to ask you questions, and thank you.
You're only asking her questions, so
yeah.
I'm all fine with that.
Him.
But thank you, Mrs. Moses. I'm honored to speak to an astronaut at all. And I am Isaac, by the way. I'm a freshman, but I do intend to go into aero and astro, and it's been something that I've always wanted to do. And my question for you is, in terms of your role for training astronauts, what equipment is utilized beforehand to prepare the trainees for the physical rigor required for spaceflight?
All their flight equipment. And thank you, Isaac. Thank you for the question. Yeah, stick with it. Go to Aero. I'm biased. So if you were to come fly with us as a private astronaut, you would train for 3 days and then fly on day 4. And the equipment that you would use in your training is your flight equipment. We don't do any, volumetric fake equipment. We don't build you up. We just throw you in the deep end right away. So the first day you'd get your suit, you'd get your emergency equipment. The second day you'd take a flight in a small aircraft to Field G. You'd be in a cabin trainer that's full fidelity, built off the same tools as the spacecraft Unity. Flight seat belts, flight seats. We customize your seat to your size. It would be your seat. You'd rehearse again on the 3rd day, and then you'd fly to space on the 4th day.
So it's open even to clumsy people like me.
Clumsy? Yes.
I've been told that I don't even walk in a stable way, but that's still okay.
Well, so then you would have to buy a second seat for someone to help you.
I would love to have the instructor, the chief instructor, sitting next to me. Do you have another question? Please.
Hi. Once again, thank you on behalf of all of us for letting us ask these questions. My name is Spruha Vashi. I'm a junior in aerospace engineering. And my question is, what is the most important lesson that you learned in your time at Purdue?
Thank you for the question, Spruhavashi. Spruhavashi. Thank you so much, and good luck with Aero. What's the most important thing I learned here? I mean, it was an exceptional education for the core competencies of engineering, but I think the most important thing I learned here was, well, it's probably a tie between humility and work ethic. I had a freshman engineering professor who pulled me aside after I spoke in a class about a space shuttle experiment, who pulled me aside and said, "You are so excited about space that your excitement for space is being confused with arrogance. And you should realize that it can come across that way, and even though you, Beth, are humble in person, you're not humble when you speak." And that was huge. That was an incredible piece of feedback that I constantly lean on, because I love aerospace. I mean, I just freaking love it. And that could be very confused for, I am great. No, I'm just a hard worker in the right place at the right time. And then the work ethic sort of goes along with that. Purdue did an exceptional job of setting the bar high and putting a lot of work in front of us. And I learned occasionally that same load exists in complicated team projects like human spaceflight. I pulled all-nighters many times at NASA. I pulled all-nighters at Virgin Galactic, and I always did so for the team. And without sort of that diligence and work ethic and expectation and that like grit of learning that I could do it and I could go the extra mile, I don't think I would have succeeded where I was. I was good in high school at English and history. I was okay at science and math, but I mean, I was not the kid who like could do it naturally. I was the kid who had to work harder. And even at Purdue and Aero, most of the kids around me or students around me would sort of do most of the assignment and have a few things they couldn't figure out and sort of, close the book at like 4 a.m. or 5 a.m. and turn in most of the assignment. And I would force myself to keep trying the problem from a different angle, even if I never went to bed. And that's the only way I sort of held my own grades-wise. I was not a straight A student. I got my share of Bs. And I loved Aero 340 Orbital Mechanics Professor Howell so much that I took it twice.
Is Kathleen here? I don't know.
So I think the work ethic is very important to learn. And if you can sort of teach yourself the grit to stick to it and be humble about the environment and yourself, it will go a long, long way.
Now, that grade, I heard the rumor that Neil Armstrong once had a C in a homework in calculus. I guess there was no grade inflation at Purdue. There still is none. And you work hard to earn it each time.
Yeah.
And having a C at Purdue calculus did not stop Neil Armstrong from being able to calculate in his head when to land.
Right. That's right.
And having taking Professor Howe's class twice didn't stop you from flying out to space 6 times and counting. And I love, Beth, what you said about these two factors, humility times work ethics. There gotta be a mathematical quantity for this. It's like the humility work ethic product, right? HWP, homework, it sounds, but you want this product to be big, right? You want both factors to be big.
Yeah.
And it's such a special spirit here at Purdue that the Boilermakers have these incredibly large humility work ethic products. Now, I want to exercise my abuse of power to ask you the last question. And then I want to show a little video clip, just a couple of minutes to the audience after that answer. I'm reminded, as your company helps to democratize access to that outer space experience. That human beings, since I guess the first human being, have been staring upward and gazing at the nightline, at the sky, and wonder, when can I be out there? And President Kennedy said in 1961, was it?
Sounds right.
Is it 61? That this nation chose to try to be out there, not because it's easy, but because it's hard. And a lot of people wonder, well, it's pretty good here on Earth. We've got work to do on Earth. Make no mistake about that. So why do I need to be out there at space and looking back down here? You've done it 6 times already. And what difference has it made in how you think about life on Earth by going out there in space?
It's made a huge difference, and it continues to make a difference as the years go on. My first flight was in 2019, and when I landed, I realized that that jerk in the meeting was just another human trying to do well on Earth. And that stuck with me. And then my next flight in 2021, the most amazing thing I saw during that flight was actually not Earth, even though I saw it again and it looked amazing again and it looked different and it stuck with me and it's still in me. The most amazing thing I saw were the looks on the other people's face with me in the cabin as they saw Earth. And I think their real humanity came to the surface and showed. And I just feel far more of a sense of life and humanity and kindred spirit and not hope, but certainty for the future now that I've been than I ever did before. I strongly believe that engineering and technology and science are going to be ever more important as humanity and the Earth goes forward. I mean, engineering is going to solve all the problems of climate change. What else is going to? Nothing. Maybe economics and politics, but engineering. And if that is done with a spirit of brotherly love and, oh, that person across the Earth is not a jerk, they're just another person, another piece of life on Earth, another piece of this magic miracle that we all live in, then it will succeed on all the right levels. I always thought I was a good, kind human. It has made it undeniable that I have to be a good, kind human.
Let's roll the tape.
welcome to Space Scotland. Congrats, Steve.
Welcome to the club, astronaut.
Thanks, Space. I like this club.
Beth Moses.